The next topic we're going to be looking at is called ratio of similarity and zoom factor. First of all, what is a ratio? Well, it's simply put as it says up here, it's a comparison of two quantities. You can really write this ratio at three different ways here. One as A colon B. The second way is you can write it as a fraction, A over B, or finally you can write it in words, A to B. And basically what this ratio is, it's what we're going to be looking at is it's going to be between corresponding sides in similar figures, and we call this the ratio of similarity. Also, we're going to be looking at what's called the zoom factor, and that's the ratio of the new figure to the original figure. And I'll show you right now what this all really means in terms of mathematics and an example here. So what we have here is we have two figures. We have the original figure down here, and we have the enlargement next to it. If you want, I mean, think of it as the original was put on a copier machine and blown up a certain percentage to make the enlargement. So if we're looking here in terms of corresponding sides, this is AB and this is A prime, B prime. So 6 and 9 would be corresponding with each other. Likewise, this is AC, this is A prime, C prime. So Y is going to go ahead and correspond with 15. And then finally, we would have 8 corresponding with X. And so the first thing we want to do is we want to see if we can figure out, well, what is the zoom factor? And as it says up here, it's the ratio of the new figure compared to the original figure. So what you want to do is you want to look at these corresponding sides here and see, wow, in which case here do we have numbers in both cases? And it's the one circled in red here. So 6 and 9. If we look at the blue ones, it's 8 versus X, or it's Y versus 15. And in those cases, both of them aren't numbers. We're looking for the numbers here. So we have 6s to 9, and we're always looking at the new figure related to the original. So the new figure is a 9, so our zoom factor is going to be 9 over 6. You can reduce that down to 3 over 2, or if you prefer, we can call that 1.5. So it looks like that our enlargement is 1.5 times as big as the original. Next, what we want to do is we want to find the missing sides here. So let's go ahead and find X first. So here's how it works here. What we can do is we can say 9 is to 6. So 9 over 6 equals. Now, since we started with the bigger figure first, we want to, if we were looking at X and 8 here, we want to have the bigger figure first on top and then the 8 on the bottom. And now what we have is we have a proportional equation here. We can go ahead and solve it. So 6 times X would be 6X. 9 times 8 would be 72. Go ahead and divide by 6. Therefore, X would be 12. That's our answer. Likewise, if we want to go ahead and find Y, what we need to do is set up a similar kind of equation here. So we can say 9 is to 6 again. Okay, so that's the red ones here. 9 is to 6. And now we're going to involve Y and 15 here. Since we started with Y, we started with the enlargement first. The 9's on top. We're going to have to put the 15 on top and the Y on the bottom. Once again, cross multiply. 6 times 15, well, that's 90. 9 times Y is 9Y. And if we go ahead and divide by 9 on both sides, we wind up with 10 equals Y. And you can do a little sanity check right here. If this is a 10, what is 10 times 1.5? Well, it's 15. Also, down here, if this is 8 and we said that X is 12, if we were to take 8 times 1.5, would we get 12? Yes, we would. So that's the way you can check your work here. So that's what you need to know about ratio of similarity and zoom factor.